Hello students. In this session, we are going to study about aromatic hydrocarbons. We are going to discuss about introduction, sources of aromatic hydrocarbons, and the difference between aliphatic and aromatic compounds. And after that, we are practicing some MCQs on this part. Benzene and all compounds that have structures and chemical properties resembling benzene are called as aromatic hydrocarbons. The molecular formula of benzene is C6H6. And the coal tar and petroleum are two large-scale sources of benzene and aromatic compounds like toluene, phenol, naphthalene. Benzene was synthesized by Berthelot in 1870 from acetylene. With the acetylene having the formula CH triple bond CH, three molecules of acetylene combine together and they form benzene. Benzene, it is also called as phenol. C6H5, it is called as phenyl group. Benzene is a colorless liquid and having characteristics odor. Boiling point of benzene is 353 Kelvin. Now here the many organic compounds obtained from natural sources like resins, these are the resins, balsams, these are the flowering plants, and oil of wintergreen. And all they possess the pleasant odor, the present a pleasant fragrance. This refers to the aroma, that is the smell. And therefore, all these compounds, these hydrocarbons, are named as aromatic compounds. Aromatic hydrocarbons, these are also called as arenes, as they contain only carbon and hydrogen. Large scale of source of benzene is petroleum, coal tar, and petroleum. Aromatic compounds are chemical compounds that consist of conjugated planar ring system. So this is a conjugated planar ring system which having the alternate double bond and single bond. And there is a delocalization of pi electrons takes place. These pi electron clouds in place of individual alternating double bond and single bonds. And therefore they are called as aromatics or arenes. And the best example is benzene, toluene, bromobenzene. These are the examples for aromatic hydrocarbons. An aromatic functional group is characterized by the ring of 6 carbon atoms. See, these are the 6 carbon atom bonded by alternating double bond and single bond. And if they are with the unused valency of this, these are referred as phenyl group. Okay, C6H5, and this is the one unused valency. This is the phenyl group. The examples of aromatic compound. The first important example is benzene, which having the alternate double bond and single bond, C6H6. Now see, these are the substituted. One is the bromobenzene. One hydrogen of benzene is replaced by Br. We get here bromobenzene. All these are the examples of aromatic compounds. Phenol, naphthalene, which contain the 2 rings. Aniline, C6H5NH2. NH2 group is present on this phenyl ring. Nitrobenzene, NO2 group. So this is the NO2 group is present on the phenyl ring. Acetophenone, in which is the benzene ring and CH3 group. They are bonded with the C double bond O, which contain the ketone as a functional group, and its name is acetophenone. Chlorobenzene. Now see the bromobenzene, chlorobenzene, these are the halobenzenes, okay, which contain the halogen as a functional group. This is the structure for benzene sulfonic acid, C6H5SO3H. Means SO3H group is present on benzene ring. So these are the examples for aromatic compounds. Aromatic compound benzene, it shows the resonance. Due to the position of the double bond and a single bond in the alternate, they show, now see, this is the bond which is present in between these 2 carbon atom is not fixed. It may be in between these 2 carbon atom. Means what we can say, there is a continuous rotation of this bond. These are the pi electrons are continuously rotated in the benzene in this ring, hexagonal ring. And therefore, this is the actual structure, resonance hybrid structure of the benzene. See, this is the difference between the aliphatic and aromatic compounds. First, we see here the percentage of carbon. in aromatic compound, they contain higher percentage of carbon, whereas in case of aliphatic compound, they contain less percentage of compound carbon as compared to the aromatic compound. You just see here the example for the benzene, which having its formula C6H6, means if there is the carbon 6 are present, hydrogen 6 are present. But for the aliphatic compound alkane, if they contain carbon number 6, so hydrogen they are present 14, means they contain more percentage of hydrogen for the aliphatic compound, whereas in case of aromatic compound benzene, they contain higher percentage of carbon. As they contain higher percentage of carbon, when we burn, they show sooty flame. Whereas in aliphatic compound, they burn with non-sooty flame. Aromatic compounds, they are in the cyclic form. They show the cyclic structure with the alternate double bond and single bond. Okay. Aliphatic compounds are open chain compounds like alkane, alkene, and alkynes. They are in the form of aliphatic compound open chain form. Aromatic compounds do not undergo the addition reaction easily. But in case of these aliphatic compounds, as they are unsaturated aliphatic compounds, means alkene and alkyne, they show very easily addition reaction. Aromatic compound like benzene, they are not attacked by normal oxidizing and reducing agent. But aliphatic compounds, they are easily attacked by the oxidizing and reducing agent. This is the type of reaction. This is the aromatic compound, they show the substitution reaction. And whereas in case of these aliphatic compounds, saturated aliphatic compound prefer substitution reaction. Means now see if you are see an example for the alkane, they show the substitution reaction. Why? Because alkanes are saturated aliphatic compounds. Decolorization, it is a property, shows the difference in between the aliphatic and aromatic compounds. For the aromatic compound, they do not decolorizes dilute alkaline aqueous chamenophore solution, which is a dark purple color solution chamenophore. They are not decolorizes by the aromatic compounds, or Br2 in carbon tetrachloride. And though they contain the double bond in their structure, aromatic compound, but they not decolorizes these alkaline chamenophore solution or Br2 in carbon tetrachloride. Carbon tetrachloride here it acts as a solvent, and Br2, which is a dark brown color, reddish brown color solution, so it not decolorizes benzene. Benzene not decolorizes its color, and in case of these aliphatic compounds, alkene and alkyne, they decolorizes dilute alkaline aqueous chamenophore solution as well as Br2 in carbon tetrachloride. And as they contain their double bond in their structure, they show this property of decolorization. Hackel rule is applicable for the aromatic compound, not for the aliphatic compound. So this is about the basic difference between the aromatic compounds and aliphatic compounds. Aromatic compounds have pleasant odor, but not all the compounds those resembles with the benzene have pleasant odor. Now here this is the example for anthracene, which is an aromatic compound which contains 3 hexagonal rings, and it obeys the Hackel rule, means it is aromatic compounds, but it is odorless. Whereas these examples, they're not having benzene ring in their structure, but they have pleasant odor, like methyl acetate, ethyl acetate. These are the esters which have the pleasant odor, chloroform CHCl3. So what we can see here, all these aromatic compounds, they are not having the pleasant odor. Now we are practicing some MCQs on this part. See the first MCQ here. Identify the correct statement which is related to the aromatic hydrocarbon. Aromatic hydrocarbon has only sigma bond, they have only pi bond, it has sigma and 2 pi bonds, and it has sigma and delocalized pi bond. And I'll read the question and MC the options carefully, and just think on it and see the correct option for that MCQ is option D. In case of aromatic hydrocarbon, they always has a sigma as well as delocalized pi bond, and they found in between the 2 carbon atoms alternate double bond and single bond. This is due to the delocalization of pi bond, and therefore the correct option is D. Select the incorrect option. Read the question carefully. What you have to choose here? The incorrect option. The aromatic hydrocarbon has a pleasant odor. So this is the correct. Some of the aromatic compounds are ring shaped. Aromatic hydrocarbons can be neither mono or polycyclic. And benzene is the simplest hydrocarbon. Now see, the benzene is the simplest hydrocarbon. This is the correct. Some aromatic hydrocarbon can be neither mono or polycyclics. They are in the both the forms, that they are monocyclic or polycyclic. Aromatic hydrocarbons have pleasant odor smell. Yes, they have the pleasant odor. So the incorrect option is some of the aromatic compounds are ring shaped. Actually, all these aromatic compounds are ring shaped, and as all these them are in the sp2 hybridized with the geometry of trigonal planar. Which among of the following is not a property of aromatic hydrocarbon? Aromatic compounds have a good aromaticity. The compound have excellent stability. They do not undergo the nucleophilic substitution reaction, but they undergo the electrophilic substitution reaction. And there exists a strong ratio between carbon and hydrogen. We have to find out here which is not a property of aromatic hydrocarbon. So we see here the correct option is option C. Aromatic compounds do not undergo nucleophilic substitution, but they undergo the electrophilic substitution reaction. Actually, aromatic hydrocarbon undergo both electrophilic and nucleophilic aromatic substitution type of reaction. See here, the fourth question is arenes are polar. You have to just find out here which is a true or false. Arenes are polar. Now see, the correct option is B, as arenes are insoluble in water. As they are insoluble in water, they are non-polar solvent. Next question is arenes are volatile, water soluble, non-carcinogenic, and mostly gases. Arenes means that aromatic hydrocarbon, benzene ring. This is also called as arenes. So what we can say here, the correct option is option A, as these arenes have a very low boiling point and therefore they are volatile in nature. Which of the following compound does not contain any benzene ring in their structure? Now see, for that you must know the structure for this example. First option is benzaldehyde, is benzoic acid, naphthalene and furan. Now the benzaldehyde, its formula is C6H5CHO, which contain aldehyde as a functional group. Benzoic acid, C6H5C double bond OH, it also contains benzene ring. Naphthalene, it contains the two hexagonal ring, two benzene ring, and therefore all they contain benzene ring. But for the furan, it not contain benzene ring in their structure. See, this is the structure for the furan, which not contain benzene ring. Benzene ring means hexagonal ring, and therefore the correct option is the furan, which not contain benzene ring. Now see, the next question is benzene undergoes which type of reaction? Addition reaction, only substitution reaction, both these, or the last option is nucleophilic substitution reaction. So the correct option is benzene. It shows addition and substitution reaction. Both type of reactions are shown by this benzene. Now see, the mainly it contains the more number of pi electrons and therefore it shows the addition reaction. And for the substitution reaction also, due to the more number of electrons, it shows the substitution reaction. Pi bonds is replaced by any other group and therefore it shows both type of reaction. The main source of these arenes are petroleum, biogas and petroleum and coal tar, and the last option D is natural gas, which is the main source of these. In the introduction part only we completed about this. This is the petroleum and coal tar is the answer, and therefore option C is correct, as these petroleum and natural gas comprise of the naturally occurring compounds. such as carbon and hydrogen in abundance, and therefore these serves as the main source of arenes. The molecular formula of toluene is, to find out here what is the molecular formula of toluene. For that you must know the structure of benzene, structure of toluene. It is C6H5CH3, means on the benzene ring CH3 group is present, and count the number of carbon and hydrogen in the C6H5CH3. Now see C6H5 and one CH3 means one more carbon is present, means it contains 7 number of carbon atom. Let's see its structure for the toluene. See C6H5 CH3, this is the toluene structure. Carbon, the 6 carbon atom in ring and one is the this one is, therefore 7 carbon in both option A and B, they contain 7 carbon atom. Let's count for the hydrogen. 1 2 3 4 5 and this 3 6 7 8 means they contain 8 hydrogen, and therefore the correct molecular formula of toluene is C7H8, and therefore option B is correct. Now see the 10th number question, MCQ. Phenanthrene is fused polycyclic compound. Polycyclic means which contain more benzene ring. So it contain how many rings? It contain dash benzene ring. It contain 2, 3, 4 or 5. So what is the structure for phenanthrene? See, this is the structure for phenanthrene. These 3 rings, but the middle one is the alternate double bond and single bond, and these 2 side rings, they pi electrons or pi bonds are in conjugation with this benzene ring, and therefore option B is correct, phenanthrene which contain 3 benzene ring. Aniline is a derivative of benzene which contain, okay, so aniline contain which functional group? Imino functional group, amino, amide or nitro functional group. Let's see, the correct answer is for the aniline. Okay, what you have to ask here, aniline means its formula is C6H5NH2. NH2 means which contain amino as a functional group. As these amides means C double bond O NH2, imino NH group and nitro NO2 group. So option B is correct, which contains C6H5NH2. See, this is the structure for aniline, which contain the functional group NH2. It's called as amino functional group. So these are the MCQs. One more MCQ. How many electrons are there in the benzene to form the delocalized electronic cloud? Means in the structure of benzene, how many electrons are in the benzene ring and they are delocalized. Okay, they form the delocalized electron clouds. 3 electrons, 4, 6 or 8. Okay, now let's see its answer for this. Now see, this is the option C is correct. Now see the structure for this benzene. These are the pi electrons, and these pi electron delocalized. The delocalization of pi electron takes place around the carbon, and they form the alternate double bond and single bond. And therefore, how many electrons are in the delocalization? That takes part 6 electrons. These the pair of electrons, 3 pair of electron means 6 electrons are they form the delocalization electron cloud. So these are the MCQ upon these part of these aromatic hydrocarbons. Okay, thank you.